name is Vindi Kansa. My matrix number is 208611. So I'm going to explain to you about trusses. Truss is a frame structure composed of a triangle or a triangle group arranged in a way that only stress and compression in the members can be induced by load imposed at the points of intersection of the component. It is built to cope with a pre-calculated load and is designed and constructed as the minimal framework that can bear the load of design. The form of a triangle or a sequence of triangles is the engineering theory behind the truss. A triangle is overstrong in geometry and can handle various loads better than most shapes. A truss is a structure composed of one or more triangular units formed by straight members whose ends are joined at joints known as nodes in architecture and structural engineering.
Okay guys, now we are going to talk about the location of the structures for trusses. Trusses are popular for bridge building because they use a relatively small amount of material for the amount of weight they can support. They commonly are used in convert bridges, railroad bridges, and military bridges. As shown in this report, trusses were used for built roofs, especially to withstand the weight on the roof. The trusses mostly can be seen on the buildings, actually on the rooftop.
Hello and Assalamualaikum. So next, I will show you the free body diagram for trusses. So in this diagram, we include the reaction forces and the external loads for the structure. So on the top of the structure, there is two external loads at joint B and joint E, which is 10 Newton each. Next, at the joint A, there is a pin, so there will be two forces acting on it, which are AX and AY. Next, at joint F, there is a pin and a roller, so there will be only one force acting on it, which is Fy. So next, I will show you the free body diagram for each joint. So this is the free body diagram for joint A and B. So next, this is the free body diagram for joint C and joint D. Next, this is the free body diagram for joint E and joint F. And lastly, this is the free body diagram for joint Z and joint H. So that's all for trusses.
Hello, Assalamualaikum. So my name is Amirul Akmal, metric number 207152. Welcome back to our presentation. And right now, after my friend has explained about FBD for each structure, I will explain about the calculation for each structure, which is trusses, machines, and frames. So let's go. So for trusses, we will take the sum of moment. Okay, I'll take the moment at A because it is a very simple, a very least unknown that have there, which is the unknown that I only have is Fy. So I will get the value of Fy directly. So by using the sum of moment at A, I get Fy is equals to 10. And also next, I use the sum of Fx and Fy in order to get Ax and also Ay. So I get Ax is equals to 0, Ay is equals to 10. And then I search for the angle, which I get 26.56 degrees. Sorry, that is a typo. So just bear with it. 26.56 degree. So next, let's go. So I using the method of join, which as you can see, first we go to the join A, which join A using the sum of Fx and Fy. Actually, for each join, the technique is almost the same, using the sum of Fx and Fy. So by using method of join, I will get each force members. Like that. Good. Alright, so at join A, I got FAH is equals to 0 and FBA is equals to 10, which FBA is the same according the same direction as in the FBD, which the forces exerted in each joint. So the direction shown is that the members is in tension. So next at joint B, let's go using Fx and Fy again. I get FCB and FHB. FCB is equals to negative 10 Newton and FHB is 22.36 Newton. Alright, so why, as you can see, FCB have negative value. Why? Actually, I put a negative value because our assumption is wrong. The direction of FCB is is the wrong way. The wrong way. So the direction of the direction of FCB for the member of CB is in compression. How about the FHB is in tension. So almost for each joint is almost the same. So let's go for joint C. For joint C, we get FDC is equals to 10 Newton, which I get in the members in tension, and FHC is equals to 0, which no force exerted in there. So at joint D, how about joint D? Joint D, I got FHD, the value of FHD only, because I only use FX. Because in the calculation, if I using Fy, I have many variables, so I use it at other joints, which can get the result. So FHD is equals to 22.36. The members is in tension. So next at joint E, I got the value of FDE and FFE, which 0. FDE is equals to 0. FFE 10. Also, the members is in tension. At joint F, I got the value of FGF and FDF. Both is equals to 0. Alright, so next at joint G, I got FHG and also FDG. Both are also is equal to 0. So we cannot assume that it is the intention or compression because we don't know the force, the direction of the force, because if there's no force there, we cannot do anything. We cannot know where the force go, like that. So at joint H, at joint H. So at joint H, this is what I got FDH, which is as the same as FHD. So that's it. The answer is 2.36. So as you can see, the same. So it is. So I can tell that our calculation is right. So let's move on.
This is a conclusion about truss. The truss is building event that allows the weight of a roof to be distributed to the outer walls for the better support. Truss give more support and allows the builders to use favored materials to achieve any construction. It allows distribution of load. It also increases the span of any construction like bridge and building trusses. Trusses also have some disadvantages, which is takes up more space and can sometimes become a distraction to drivers. Okay, thank you.
So continuing to frames, frames are rigid structures. They maintain their shapes with or without external loads. In frames, there can be both vertical members and members that are inclined on an angle. Frames can be analyzed by various methods. However, the method of analysis adopted depends upon the types of frames. So the behavior of structure subjected to horizontal forces depends on its height to width ratio. The deformation in low-rise structures, where the height is smaller than its width, is characterized predominantly by shear deformations. In high-rise building, where height is several times greater than its lateral dimensions, is dominated by bending action. There are two methods to analyze the structure subjected to horizontal loading.
Next, we are going to talk about location of the structure for frames. Frames mostly can be seen in engineering, especially in robotics. A tool frame tells the robot what the tool's center point is. If this is not done, the robot control makes its calculation based on the robot's gripper faceplate. Frames were used in joints of arms, legs, and other joints in other body parts. In this report, the structure that's shown is used for playing games, especially basketball, which is basketball hoop. The structure was designed to withstand the forces and long last. So in basketball hoop, we can see a lot of frame forces which is used in basketball hoop.
So next, let's move on to the free body diagram for frames. So this is the free body diagram. In this diagram, there is two external loads acting on the structure. So first is the board, which is 150 Newton, and next is the ring, which is 200 Newton. So this is the free body diagram for ACE part and FD part. So this is the free body diagram for BCD part and AB part. Next, this is the free body diagram for the EA part. So that's all for frames.
To our frames. So frames, by using free body diagram of FD, we can find dx and also dy. So okay, first we need to search for the angle of the triangle. Here is the triangle. So by using tangent, so an easy way, if you want to know, you can use soh kah tua. Soh kah tua, which sine is equals to opposite over adjacent, cos is equals to adjacent over hypotenuse, and also tangent is equals to opposite over adjacent. So now I'm using tangent. Tangent is equals to opposite over adjacent. So in order, if I get that, I get the angle is 59.06. So using the moment at D, I will get force of EF. So FEF is equal to 376.8 Newton. So by using the sum of Fx and Fy, I will get dx and also dy. So I will get dx is equals to 193.7, dy is equals to 673.2. Okay, next, let's go to the calculation, to the more complicated calculation. So first thing first, in order to have the solution of frames, we need to find the global equilibrium. The global equilibrium is actually where the base is located on. So actually, in our diagram, I don't put any point, any letters for the base. So I just assume that the base is H. So we put the force because it is what you call that, tertanam in the ground. So we put X and Y. Yes, so we know that the basketball pole will not move anywhere. So will not move to the left or the right. So X we can consider as 0. So how about Y? Why? Because we have the force at the ring. So we sum it all. So we get 350 Newton. So in order to find global equilibrium, we use moment of H. Global equilibrium is actually the moment of H. So moment of H minus with moment at 150 Newton and also moment at 200 Newton. So we get moment of H is equals to 1262.5 Newton. Meter, sorry. So next, we are using FBD of ACE. We're using sum of moment at C. So we get the force of AB. The force of AB is equals to 875 Newton. Next, so we use sum of Fx and also Fy. As you can see, yeah, like that, like this. So we got Cx and also Cy. This is the thing that we want to search, which the force at C.
Okay, this is a conclusion about frame. The frame and machine are built-up structural and mechanical system consisting of multiple parts assembled in several possible ways. The method of analysis is the same with machines. The solution to this system usually requires the drawing of the free body diagrams of individual parts and the application of the equilibrium equation. Therefore, must be careful in recognizing the existence of two force members that will identify the direction of the unknown force. When frame is broken up into multiple parts, the forces and movements present at the points of separation must be shown on the free body diagrams of the separated parts in a manner consistent with the third law of Newton. There is the forces and movement are shown as equal and opposite on the two parts that have been separated. Thank you.
So the last one being machines. Frames and machines are structures containing multi-force members. Machines are designed to transmit and modify forces. They may or may not be stationary and always contain moving parts. Frames and machine are structures similar to trusses, except that they have at least one member that is multi-force member. A multi-force member is an independent piece of system that has three or more forces acting on it. Machines are non-rigid structures that depend on supports to maintain their shapes, which are usually non-unique.
Next, we are going to talk about the location of structures for machine. Machine can be seen in a lot of places. A machine tool is a power-driven machine, for example, a lathe, miller, or grinder, that is used for cutting, shaping, and finishing materials. Nowadays, mostly the common machines are working with forces that generated by the electricity. This is because the machine tools makes the work a lot more easier and done as soon as possible. But there still have some hand tools, which is in this report the tool that have machine application in it is a hand tool that can be used for cutting wires and cutting small things.
So next, I will show you the free body diagram for the machines. So as you can see, there are parts labeled A, B, C, D, and E. So the external forces for this machine is at A, 50 Newton, and E. So next, I will show you the free body diagram for the parts of the machine, parts of this cutter. So first is the free body diagram for part ABC, and free body diagram for part CDE. So that's all for machines.
Move on to the machines. The machine parts, a bit simple, where we got our item is bolt cutter. So as you can see just now, they are explained about FBD. So from FBD of ABC, we can find the force of CY, BX, and BY. Okay, in order to find CY, we only use the sum of moment FB at B. So we got CY is equals to 5000 Newton. How about Fx and Fy? Fx we will get Bx, Fy we will get By. Bx is equals to 0, and also By is equals to 5050 Newton. So the next thing, which we use a free body diagram of CDE. So we just use the moment at C, and also the force at x, the sum of force at x. So we got CX. Just now we just searching for CY, right? So now at FBD of CDE we can search for CX, and also at moment of C we got E. We got at point E how much the value. So E we got 500 Newton. So I think that's all from me for the part of calculation. Thank you for watching.
Conclusion about machines. The frame and machine are built-up, structural and mechanical system consisting of multiple parts assembled in several possible ways. For example, the parts could be pin connected or welded together. The primary difference between frame and machine is that there are moving parts in machines and not in frames. The method of analysis is the same with frames. Although machine involve moving parts, we analyze the system at one instant in time when the position of individual parts and the applied loads are clearly defined. Solution to this system usually requires the drawing of the free body diagrams of individual parts and the application of the equilibrium equations. Therefore, must be careful in recognizing the existence of two force members that will identify the direction of the unknown force. The machine is broken up into multiple parts. The forces and moments present at the points of separation must be shown on the free body diagrams of the separated parts in a manner consistent with the third law of Newton. There is the forces and moments are shown as equal and opposite on the two parts and have been separated. Thank you.